Two parallel conducting plates are separated by a distance d, and the charges on the plates are q and negative q. Electric field is constant between the plates. A particle of mass m and charge positive q is released from rest at the surface of positively charged plate. Calculate the velocity of the particle just before it reaches the negative plate. Let's draw a diagram first. Positive plate and negative plate. And they are separated by a distance d. A particle of mass m and charge q is released from rest. V initial is 0. Now calculate the velocity of the particle just before it reaches the negative plate. So now, let's say the particle is right here. We are going to calculate V final. The velocity can be determined either by using the work done on the particle by the field, or by calculating the electric forces, acceleration, and solving using kinematics. We can write the kinetic energy for the beginning, 1/2 mv initial square, and the potential is qv initial. When the particle hits the other plate, we can write the kinetic energy 1/2 mv final square, and the potential energy is qv final. Because initial speed is 0, so this term is 0, and the potential energy is qv. When the particle hits the other plate, kinetic energy is 1/2 mv final square, and there is no potential energy there. The potential term is 0. After rearranging, we have now 2qv over m. Square root of this term is v final. So let's remember, potential energy was charge times potential qv, and also the potential was given in terms of electric field, E times D. From this we can rewrite V final as 2 times Q. Instead of V, we are going to write E times D over M, and the square root of the whole term. The second method is using kinematic methods. F net is m times acceleration. Electric force is F equal Q QE. And the net force is the electric force between the plates. Therefore, we can write m times A is Q times E. So the acceleration is QE over m. Now remember, in velocity for a later time, we have a kinematic equation, V final square equals V initial square plus 2 times acceleration times distance. You can use this equation alternatively to answer the question. V initial square is 0, and 2 times acceleration term, which we just found, QE over m, times distance. After rearranging, we find the same answer which we did above, 2QED over m, square root of 2QED over m.